All right, today we'll be working with story problems that have systems of equations. I'll be showing you a couple of examples of how to set up these problems. A company wants to mix two types of candy in a bag and earn the same amount of money as if they sold the candy separately. The first candy costs $2.45 a pound, and the second candy costs $4.17 per pound. How many pounds of the first candy must be mixed with 3 pounds of the second candy to sell the mix for $3 per pound? All right, so there's a lot of information in here, and we need to break it down into smaller chunks so that we can understand what they want. So the company wants to mix two types of candy. So really we're looking at, okay, we need an equation for the mixed candy. And it says they want to earn the same amount of money as if they sold the candy separately. So we need another equation to find out the money that we'd make if they were separate. So the separate one is usually the easiest one to write the equation for. So we're going to do that one first. The first candy is $2.45 per pound. And the second candy is $4.17 per pound. And that's going to give us a total of some amount that we don't know. It also says how many pounds of the first candy. So we don't know how many pounds. We're going to put an X next to this one because we're going to multiply how many pounds by the price. The second one, it says we're going to have 3 pounds of candy. So this amount of money times X pounds plus this amount of money times 3 pounds will give us our total amount of money that we are going to make. Now, when we mix this candy, we want to have 3 pounds of this one and a certain amount of pounds of this one, and together we're going to sell it for $3. So the money that we are going to earn per pound is $3 per pound. And how many pounds do we have? This is the tricky part that most students can't figure out. We have X amount of pounds from this one and 3 amount of pounds from this one, or in other words, we have X plus 3 pounds that we're going to sell at $3 per pound. So we have the X and the 3 added together to make the pounds for the mixed one. Now to solve this, we're going to use substitution because notice we have y equals in both cases. So I'm going to substitute this 3 times x plus 3 into the y down here for this equation. So I'm going to have 2.45x plus, now I'm going to multiply this out, so that would be 12.51. And that's equal to y, which is this piece up here, multiplying out is 3x plus 9. Now I can continue solving. I want to get the x's on the same side, so I'm going to minus the 2.45x onto the right side. And I'm also going to subtract the 9 onto the left side. So on the left side, that's going to give me 3.51. On the right side, that's going to give me 0.55x. Now I just need to divide. So I'm going to take my 3.51. I'm going to divide that by 0.55. And that tells me that it's got to be approximately 6.38. Now remember that x represented the pounds of the first candy. So it's got to be 6.38 pounds of candy, or approximately 6.38 pounds. Here's my second example. A person swam downriver a certain distance in 2 hours and then turned around and swam back to where he started in 3 hours. If the swimmer can swim 6 miles per hour in still water, how fast is the river flowing? This is a question that most students struggle with because they don't remember the equation. The distance is equal to the rate multiplied to the time. They also don't recognize that we have two different rates. We have the swimmer and we have the river, the current. So I like to say I'm going to use X for the swimmer, how fast the swimmer is going, Y for how fast the river is going. So really, I have two rates, X and Y. So I'm using the equation that distance is equal to the rate, which is X and Y, multiplied to the time. Now, if I add Y, that means I'm swimming downriver. If I subtract Y, that means I'm swimming upriver, or I'm swimming into the current, so it's slowing me down, or I'm swimming with the current, so it's making me go faster. Now that we have our two equations, we can then plug in the numbers from that the story has given us. So a person swam downriver for a certain distance in 2 hours. So it gave us the time, it did not give us the distance. So I have the time, I don't have the distance. My time is 2. Then they turned around and swam back to where they started in 3 hours. So again, I don't have that distance, but I do have the time, which is 3. Now, if the swimmer can swim 6 miles per hour, so that is how fast the swimmer is going, which we said was the X value. So I put a 6 in for this one and a 6 in for this one. How fast is the river flowing? That's the variable that I don't know. So on the top one I have plus y. On the bottom one I have minus y. Now I have two equations. I have these two equations here. And I can use those two equations to solve. Now again, this one is simple substitution. I'm going to substitute this piece into the top one, or you can substitute this one into the bottom one, either way. So when I substitute, I'm going to multiply this in. So I'm going to have an 18 minus 3y, and that is equal to a 12 plus 2y. Now I'm going to get variables on the same side. So I'm going to add the 3y to both sides. At the same time, I'm going to subtract the 12 from both sides. So that's going to give me a 6 on the left side and a 5y on the right side. Now I can divide and I get y is 6/5, or in other words, 1.2. Now remember y we said was the speed of the river, which is what we're trying to find. And this is in miles per hour. So the speed of the river is 1.2 miles per hour.